In the storyboard, we're going to take a few sources of data, static, some EVX or MDM platform based, and some streaming from various sensors and bring it together in virtualization. Within virtualization, you're going to see the ability to point to and consume multiple data formats and data sources, bring those data elements and the metadata associated with them together to understand and discover relationships. Given those relationships that are discovered, how do we take them and expose them out to the business and optimize the ability to consume the data effectively? And then ultimately, how do we take that exposure point and deliver it to the business? Whether it's a SQL query, whether it's a web service call, API call, or it's a real-time message. Let's begin our story today at the Data Virtualization Studio. Think of this as your data engineer's developer workspace. This is where you begin to point to the various data sources available, begin to create the virtualization, the views, the cache. Out of habit, I like to look at a couple of tiers of data, if you will. The physical layer, the business layer, and the application layer. Now, these are just logical representations of how I like to organize my information, but it can change from implementation to implementation. So if we begin at the physical layer, this is where we are able to go and point to a new data source, leveraging one of the almost 300 connectors out of the box. The various technologies, protocols, as well as streaming data with access to TIBCO streaming framework. Now, what we've done is we've gone ahead and created a couple, and I'll walk you through them very quickly. First of all, you have a series of static data files that come from an ETL job, for example, or from an upstream data provider that sends over CSV files in an FTP location. So we bring those together, things like allergies and in simple data that comes from an external source. Now, what I'd like to do is also point to a master data source, right? So for example, we have EBX, which is our master data management platform, and we have a patient master repository. Now, this is directly coming from EBX, and it's exposed metadata about the patient information underlying it. And these views are directly consuming from the underlying tables and views within the master data platform based on what the business has determined as shareable and available for consumption. Now, alongside the reference data, the master data, we're also pulling in some data warehouse data from MS SQL, right? So there is historical content around medications and observations that we want to bring trending analysis and some analytics forward for. And finally, we have streaming data. Now, this is a stream of content coming from our bedside, right? The patient's heart rate, blood pressure, temperature coming through as real-time, current, millisecond available data. Now, as a data engineer, I bring all the sources together. I begin to create my logical consolidation of my views. And now I begin the actual valuable exercise of modeling my data. So let's say I don't know where to start. Now, as a business user or as a data engineer, I can pull up my modeling. And what it does is when allocated towards the right assets, it goes and begins to determine relationships or proposals between them based on column name, number of matches, the proximity of the match. Now, if I choose to like it, I can click any given view and create a view directly using the relationship. So I can use the metadata discovery engine within the virtualization platform to bring possible joins together. And again, this is agnostic of the source, the structure, the velocity of the data, right? My master data, reference data, and streaming data is coming together to give me the ability to create insight. Now, given a view, I'd like to go ahead and pull together a couple of possible sources. So this is my patient data pulled alongside my observation data with the patient ID as a join. Now, simply, I can take a look at the sample data below these two sources. One is master data platform, and one is coming from my data warehouse and my streaming data. But at this point, I can also look at the lineage. So where does my data come from? Where are the various attributes and sources of that information, and what content in that view? Now, this is great for an analytics user. This is great to publish. To understand that this attribute in this column, in this cell, in this table, in this pie chart came from these sources through this process and through this map. So it's a great way to get through some data forensics and understand why does my data look the way it does. Now, once I get to a point of understanding some of the business assets and the business-facing domains I want to expose, what do my applications need? Now, I recognize that one of my application layers needs a consolidated view that brings together patients, allergies, care plans, medications, and observations. So I, again, drag them from my various elements of my canvas, pull them together, create the joins. I validate the content that's coming through, and also can get into caching. How do I make sure that what I'm pushing to the business user is responsive? It has the data up until the point at which I need it, and my DB server isn't bogged down by trying to feed hundreds of parallel consumption points or thousands of consumption points every minute or every hour. So this cache configuration allows me to decide what do I pin, where do I pin it, how frequently should it get updated, and what do I want to optimize based on the business view. Now, couple this with our monitoring tools, and what you've got is the ability to do an intelligent cache. Understand the trends of utilization over time, understand the patterns of usage, and programmatically begin to optimize and delete and refresh caches without human intervention at all. Now, given an endpoint, simple as right-click publish, and what I can do is publish that data via a database endpoint. So my analytics users have the ability to do a select star from view and get all the underlying data pulled together from my streaming sources, from my master data sources, but I can also directly publish it as a web service. And the great thing about the web service is this begins to go into the connect conversation of how do I take my underlying virtualized data platform and expose it to the business or expose it downstream programmers as a RESTful API. Out of the box, we have the ability to publish a Swagger page to allow your downstream data consumers to investigate, understand the payloads of inbound and outbound data exchange and begin their development lifecycle as you continue to populate the sources and to populate the data underlying these API points. As you saw, going from the data sources to views, to the business views with caching and optimization to a published endpoint, whether it's a JDBC endpoint or a REST API endpoint, was done without programming. Right? I don't need to know SQL. I don't need to know Java. I don't need to know any of the programming language to do so. As I opt into more and more complex scenarios, the options of going to SQL and the options of going to more advanced coding logic are available. But the idea around the TIBCO DB platform is to be able to provision data quickly, to be able to understand and try exposure points quickly, and to be able to find what works and therefore cache, optimize, and scale it for consumption.